Hey, Christina here with Frequency Fridays. Welcome back for our brain series. Today we're going to be talking about action potential, and I'm starting out with action potential because it really paints a very clear picture of, for one, we are electrical beings, and if that is the truth and that is the case, we should really be focused on nurturing our electrical selves, right? It only makes sense. Right now, I'm really genuinely curious about the brain and how it functions because it is the control center. Everything is connected to our brain, and it's just our main communication station, and we are on a journey together to learn about this magnificent tool we have, the brain, the mind. So again, here is the brain, and it's made up of so many different parts. It has lots of structures which each have their own function, and we'll get more into that. So in Western medicine, they don't really tend to your electrical self. So that is why I am delighted to have stumbled across Solex. So let's dig in. All right, so we've got a neuron here, and about 90 billion neurons will make up the actual structure of the brain. The more that I dig into how we're designed, what we're made of, how we operate, I'm just mind blown more and more. I think that while we have discovered a lot about the brain, since like 1960 is really when they began to study the brain. Of course, a lot has been learned, but we'll never know all there is to know. And I think that's because we're not supposed to know everything there is to know. But we know enough to help us in our daily lives in a very practical way, and that's really my objective. So I hope that you gain some value from this brain session on action potential. What is action potential? In a nutshell, it is the rising and falling of voltage, okay? Because our brain is very electrical, and these neurons are sending electrical signals pretty much constantly. So let's just start out with the structure of a neuron. So we've got the soma here, which is the body of the cell. And then we've got the dendrites that connect to the body of the cell. And then we've got this axon. And then we've got the axon terminal. And I also learned that there are voltage channels on the walls of the neuron, on the walls of the axon. Neuron lives at a resting voltage, and that resting voltage, it's called the resting membrane potential, and it is sitting at a negative 70 MV. Neurons are surrounded by ions, and ions are also known as charged molecules, both negative and positive. All right, so we've got phase one of the action potential process, and that is stimulation. So have you ever considered what gets a neuron excited? What stimulates a neuron? What gets a neuron into action? These things are happening so very rapid. So a couple of very common examples is, reaching to grab my water. That is an action potential has taken place in order for my muscles to do what they need to do to grab this bottle of water and then hold on to it. Thinking about something causes an action potential. Smelling something causes an action potential. So those are just some very basic, common things that we don't even think about potentially as causing action potential in our brain. And so when I'm saying action potential, remember that means the rising and lowering of voltage, electricity traveling and moving within your system, within your brain. So it's really your system because, you know, it's activating my hands to demonstrate some flow. If the resting membrane potential is -70, what causes a neuron to fire? When that voltage reaches a -55, that is the signal that takes it into the active potential, that gets it to fire. How about that? So when the neuron is sitting at -70, just resting, minding its business, doing nothing, hanging out, and then I want to grab this bottle of water, signals are firing off, and so it reaches that threshold of -55 voltage, and so that action potential shoots off. So these stimulations, the stimuli, activates specific neurotransmitters. And so, you know, there's various neurotransmitters and they each have a role and function to play. You know, I really love to get into the how of things. So, you know, previously in the energy fundamentals lesson where we were talking about cellular intelligence, we spoke about how there's receptor sites and channels, right? So the same process with every cell. So again, on the neuron, there is receptor sites. So the transmitter gets the signal that I want to pick up this water, so it shoots the neurotransmitter required, and it binds to the dendrite receptor, which opens up a channel allowing sodium to come inside. And when the sodium comes inside, it's entering into phase 2, which is depolarizing the neuron.
Can you take a break?
Pause. So again, I hope that this quick lesson brings you value. Most importantly, I hope it reminds you that you are fearfully and wonderfully made. Your brain is a tool. Your brain is to be your servant, not your master. And so I really hope that this lesson, this series on the brain, will empower you to use your brain and your mind as the gift and the tool it was designed to be. Many blessings to you, and I'll see you next week. Take care.